So let's understand what inferencing is and how it's implemented in different scenarios. So at its core, inferencing is the process of using a trained model to make predictions or decisions on new unseen data. And there are two main ways we deploy models for inferencing. The first one is the real-time inference. So real-time inference is when you need immediate predictions on demand. And here the model processes one prediction at a time with a low latency requirements. For example, when a user inputs a question, the model needs to respond immediately. And batch inference, on the other hand, is when we process multiple predictions at once. Instead of immediate responses, these are typically scheduled jobs that run on collected datasets. It's like analyzing customer feedback overnight. Now, when we talk about where inferencing happens, edge computing is becoming increasingly important. And edge devices are computing resources that operate at the network edge, close to where the data is generated. And this is crucial for inferencing because it determines how quickly and efficiently we can make predictions. The key aspect of edge computing for inference is that we're processing data where it's getting generated, with reduced dependency on cloud connectivity. And this brings us to the two main approaches for deploying inference models: small language models on edge devices and large language models in the cloud. When we deploy a small language model on an edge device, we are optimizing for very low latency since the model runs locally. And this means we can make predictions even without internet connectivity. But however, we are limited by the device computing power. So these models are typically smaller and more focused in their capabilities. In contrast, large language models deployed in the cloud offer more comprehensive capabilities, as we already know, but come with a higher latency due to the API calls over the internet. And these models require constant internet connectivity and have higher computational requirements, but they can handle more complex inferencing tasks. So the choice between these approaches depends on the inference requirements. For example, do you need instant predictions? Can you tolerate some latency? Do you need offline capability? And so on. So it's important for you to know the differences here because this will be tested on the exam. So the key points are inferencing is actually when we put our model to work. We have seen now here the two different types, the real-time and the batch, and also discussed the inferencing on the edge domain, where we then have two options with the small language model locally on the device or with an API call with its trades-off that you should need to know. Thank you for watching. I hope you liked this one and see you in the next one.